Hey guys, welcome to day 2 of your spring break challenge given to you by your teachers in a packet to do 5 problems each day. So today I'm going to be showing you guys numbers 6 through 10. So in question 6, which was like number 5, which we finished yesterday, says to evaluate each using the values given. So we have 2 values actually. We forgot to add that x equals 5 here. Okay, so we have 2 values or 2 unknowns that we are going to be substituting with these numbers right here before we can evaluate. And the reason we've got PEMDAS down here on the side is because we're going to be evaluating that using the order of operations once we get them substituted in. So we've got z equals 3 and x equals 5. So where we see a z, we're going to put a 3, and where we see an x, we're going to put a 5. Right here, these two next to each other mean z times x. What I tend to do is just put them in parentheses. So 3 and 5, since we're substituting in those numbers there. This means the same thing. This still means 3 times 5, or z times x, plus 6 plus z, which is 3. All right. Now we're going to use our order of operations in order to solve this. We have parentheses. We've got that 3 and that 5, which kind of equates to multiplication. So we're going ahead and doing that first. 3 times 5 gives us 15, plus 6 plus 3. All right, so parentheses are out of the way. There are no exponents. There's no multiplication, no division, but we do have addition as our last operation. So we're just going to do it in order. 15 plus 6 gives me 21, plus 3, if we evaluate that, gives us 24. So our answer to number 6 is going to be 24. Number 7. So number 7 through 10 starts a different kind of math problems where we're having to simplify each expression. And what simplify each expression means that we shouldn't have any terms that are split together, and we shouldn't have any more parentheses. So first thing we're going to need to do, just like we would in PEMDAS, is we need to get rid of the parentheses somehow. So in order to get rid of these parentheses, we're going to use the distributive property, which means we're going to take this 10 that's outside of or this negative 10 rather, that's outside of the parentheses, and distribute it to everything inside the parentheses in order to get rid of the parentheses. When we distribute, the operation is always going to be multiplication. So negative 10 times 8b is going to give me negative 80b, and then negative 10 times negative 8 is going to give me positive 80. And then we're going to need to, bring that plus 4b down as well. We're checking to see if we have any like terms to combine. And specifically, I'm looking at this negative 80b and this 4b, and those two are like terms because they have the same variable with the same exponent, which is going to be to the first power right there. So we can combine those two. Negative 80 plus 4b is going to give me negative 76b. Ooh, my 6 kind of looks like a b, but that's a 6, right? And plus 80. I can't combine negative 6b and plus 80, so this is going to be my final answer. I know it's hard sometimes when our answer is not one number or one term, but this is good enough. This is our simplified answer for number 7. Number 8, we're also simplifying. We've got some exponents in this one here. That ought to be interesting. Same thing. We want to make sure all our terms are combined, and we want to make sure there are no parentheses when we simplify. So in order to get rid of those parentheses, this 4x out here on the outside is going to have to be distributed to everything inside the parentheses. In this case, we have x and minus 5. So when I distribute, I multiply. So I'm going to bring this 6x squared down. And we've got plus 4x times x. Well, 4 times 1, which would be the imaginary coefficient here, is 4. And then x times x is x squared. okay, and that's going to be true for any x times x you ever have. All right, then I got 4x times negative 5. Positive times a negative is going to give me a negative, so I know I'm going to have a minus right here. 4 times 5 gives me 20, and then x times 5 is going to give me that x on the end there. Okay. Now I'm looking for any terms that I can combine because they are alike. So I've got this 6x squared and this 4x squared. The reason they are like terms is because they both have an x squared. All right, so I can combine those. Be careful not to combine it to that negative 20x. So 6 plus 4 gives me 10, and that x squared stays the same because we're combining them, we're not multiplying them. All right, minus 20x. All right, we have simplified. We cannot combine any more terms. Therefore, 10x squared minus 20x is your correct answer. All right, moving on to number 9, which is the same thing. Okay, we are simplifying again. This one is a little bit tricky, but we're still going to be getting rid of the parentheses. So when I'm looking at this question, first off, okay, the imaginary coefficient in front of each of these parentheses is a 1. Over here, it's a positive 1, and if I multiply everything in the parentheses by positive 1, everything just stays the same. So I can just rewrite those terms without the parenthesis. Oops. Okay, and that's a 4, just so you know. But over here, we've got a negative 1, and we're still multiplying it by everything inside the parentheses. The numbers won't change, but the signs will. So negative 1 times positive 8 gives me negative 8. Negative 1 times negative v to the 4th gives me a positive 2v to the 4th. Oh, that's a 4 again. And then negative 1 times negative 2v is going to give me a positive 2v. All right. So all we've done is distribute using the distributive property and changed our signs in some places where they needed it. So now I've got a lot of like terms I've got to combine. So right here I've got an 8. The only other thing I can combine that 8 with is that negative 8. And I'm going to get 0. Okay, I'm going to get 0 for that one. So now we're going to go on to our next like terms, right? We're just going in order right now. This negative v is like this 2v. All right, so negative v plus 2v is going to give me a positive 1v, which we can just later on, we can just write it as a v. All right. And then our last terms, we've got this negative v to the 4th, and we're going to be combining it to this positive 2v to the 4th, which again is going to give us a positive 1v to the 4th. Okay, that's going to be the outcome of that. All right. Last but not least, because this is technically a correct answer, okay, we could leave it written like that if we wanted to, but let's go ahead and simplify that into standard form, all right, which means that our highest exponent is going to go first. So our highest exponent here is going to be v to the 4th, so I'm going to write that v to the 4th first, and then our next highest is this v, all right, because technically 0 has a v to the 0th power, and this one has v to the 1st power. So we're going to add that one in, so plus v, and then we don't have to add this 0 in, but we know it's there if we want to. So this will be our more correct answer. Oh, my C's look a little funky. All right, on to number 10, which is our last problem for today. Okay, same thing. Remember that you've got a 1 in front of these parentheses. All right, that's the number or the coefficient in front, and you're just going to distribute still to every single thing in the parentheses. But remember that positive 1 doesn't change anything. So basically, we're just getting rid of the parentheses. So I got 7p cubed plus 5 minus 7p. And then same thing over here. There's no tricks or gimmicks or negatives. We just got a positive 1 in front of there. So all of our signs and our numbers are going to stay the same. And now we're just combining like terms. So we can go ahead and start with this 7p to the third. I'm not seeing any more p to the thirds, so that's just going to stay the same. Okay, we can cross it out as we go if you want to. That's entirely up to you. This 5, all right, remember that would be p to the 0th power. This 5 is going to be like that -4. They're terms that we can combine. So 5 minus 4 is going to give me a +1. Okay, done with those two. Now I've got this -7p. I'm not seeing any more p to the first powers. So this -7p is going to stay the same. So -7p. 8p to the 4th. Oh, I'm sorry. This should be 7p to the 4th, shouldn't it? Good thing you guys are catching me there. Alright, so this should be 7p to the 4th, -7p to the 4th. Okay, so this -7p to the 4th and this 8p to the 4th are going to combine to give me a 1p to the 4th. Right, see, teachers make mistakes too. Oops, and my 4s are just not with me today, right? Okay, so those two are done. Okay, those were two terms that were like. And then we've got this 3p squared, not seeing any more p squareds, so we're just going to keep that one the same. Bring it on down. All right, positive 3p squared. So we want to make sure that we write this in standard form because it's just nicer. Okay, and you're going to need to anyway later on, so we might as well start doing it now. So we're looking for the highest exponent first. That p to the 4th is going to be your highest exponent, so we're going to start with that. Okay, p to the 4th power. And then our next highest is that p to the 3rd, so I'm going to add 7p to the 3rd. And then we've got 3p squared. Okay, and then we have that 1. All right, remember that would be p to the 0th power, but we don't have to write p to the 0 because it's equal to 1. All right, those are your 5 problems for today. So good luck tomorrow, and enjoy the rest of your day. Bye.